So I know you for a few days you have been at home after your board exams, and maybe you lost touch of like how to study, and maybe you were distracted. I don't know, maybe you guys were studying like good students, I don't know. So we will start from the like very basic chapter, that is units and measurements in physics. Okay, even though it's a very small chapter, it has a huge impact. As we discussed yesterday, around 24-28 questions were asked in the past 8 years. And one more suggestion, if you are looking for the PYQs, like we will be solving PYQs in our class, and you guys also should like try at least 10 questions per chapter, like every day after our class. Okay, so we will start with the units and measurements chapter. Let's see. So what are the topics in this chapter that we will be studying? Physical quantities and units, measurements, errors in measurement, significant figures, dimension analysis and its application. So these are our topics. In this I will tell you errors, dimension analysis, these are the most important ones. Then significant figures and like vernier calipers, those questions will also come, but most of the time errors and dimension analysis questions is the one that will come. Okay. Sorry. A small difficulty, please wait. Okay, so starting with physical quantities and units. Physical quantities, you already know fundamental quantities are there, then derived quantities are there. What are fundamental quantities? They are like basic quantities which we define everything else with. So those include mass, length, time. Then there are 7. Do you remember those? I hope you remember those. Can you give me a thumbs up if you remember the fundamental quantities? Hi, are you guys listening? If you are listening, please give a thumbs up if audio and visibility is there. Okay, I am not audible. What about others? Is it for everyone? Okay, let me check that. Okay. Hello. What about now? Is it okay now, students? Please put a message. Okay. So I was asking, like, do you guys remember what were the fundamental quantities? How many? Okay, very good if you remember that. There is mass, length, time, then temperature, amount of substance, then like luminous intensity is there, but that you are not going to use. Okay, and like electric current, these are the 7. Luminous intensity we won't be using, but other 6 quantities are important to us. Then comes derived quantities. Okay, derived quantities means we need the fundamental quantities to describe them. For example, velocity. Velocity is displacement by time. So displacement is basically our length by time. So we need 2 fundamental quantities to describe what is velocity. Next, if we take the force, force is mass into acceleration. Mass, fundamental quantity. Acceleration, again length by time square. So we need fundamental quantities to explain what are derived quantities. That is the difference. Okay, and a physical quantity is expressed with magnitude and unit. Okay, let's, for example, if we say 28 meter, in this 28 is the magnitude, meter is the unit. These things you already knew. But what we use with it, let's say there are multiple units. For example, for saying length, we can use meter or centimeter or millimeter. There are so many quantities are there, so many units are there. So how to express the physical quantity in such units? What do you mean by N1 U1 equal to N2 U2? Let's imagine this pen. Let's say this is 15 centimeter in length. So first unit I am taking what? 15 centimeter. Okay, that is one unit. I can express the same in meters also, right? So what will be that? In meters, this thing will be 0.15 meter. Yes or no? So both are equal, right? But magnitude changed. N1 15, N2 0.15, U1 centimeter, U2 meter. This is what meant by this equation. So we can convert from one unit to another, but what will change? Magnitude will change. Is it clear for all? Sorry. Okay. So let's see what else is there. Now you can see on the screen 1 calorie is equal to 4.18 joule. Now I am giving you a question. Convert 5 joule into calories. Oh, sorry. Answer is already on the screen, so I will not show that. You guys please try. Okay. We have 1 calorie equal to 4.18 joule. You have to convert 5 joule into calories. How to do that? See. What is given? Calorie to joule conversion is given. Now we have to do the reverse. So first, if you take 1 calorie equal to 4.18 joule. Okay. Then we can say that 1 joule equal to what? 1 by 4.18 calories. Yes. Then we can say that 5 joule equal to 5 by 4.18 calories. If you calculate this value, you will get what? Like 5 joule equal to how much calories? Is it clear? Some people are answering 1.2, 22. Let's see. Did everybody solve using this formula only? Okay, so this is how you should try with every conversions. Let's see that. The answer is 1.19 calories. So that's why you are getting like 1.2 after rounding off. Okay, so this is the correct answer. Now let's see physical quantities and units. We already discussed fundamental quantities: length, mass, time, electric current, temperature, amount of substance, luminous intensity. What are their units? Meter, kilogram. SI units, okay? Meter, kilogram, second, ampere, Kelvin, mole, and candela for luminous intensity. Then you have seen the supplementary units also: plane, angle, and solid angle. They are dimensionless quantities, but they have units. Remember this, okay? Plane angle and solid angle are dimensionless quantities, but they have units, that is radian and steradian. Is it clear? Why we need such quantity is because here we have nothing to talk about the direction, right? Like direction is a basic quantity that we need to mention. So that to mention the direction also we have these supplementary units. Okay. Now what is plane angle? What is solid angle? As you can see here, plane angle is related to a circle. Okay, so if theta is the angle subtended by this and s is the arc length, you know this formula, arc length equal to like r theta, radius into theta is arc length. This equation you already knew. So theta equal to arc by radius, that is plane angle and unit is radians. Steradian, if you compare, it belongs with a sphere. Okay, it is a solid angle and it is represented by like their arc by radius. So instead of arc we will take this area. Okay, so area by radius square will come. I hope everybody understood. Is it clear? Radian and steradian. Okay, now let's see. For measuring, you must have heard of parallax method. I think in 12th you were doing a practical, that is lens, like optic bench, focal length of lens you have to find. There what you did, like you did find the image using parallax method, right? So similar way, there is a method called parallax method. There are two uses for it. First use is, let's say an object is at d distance. This is a star and this is two locations on earth and it is at d distance from earth. Okay, and we can find that d distance by what? Our same equation we used, arc equal to radius into theta. That same equation we can use here. See, here first we observe that star from O1 position, then we go to O2 position and observe the star. So the star is making a theta angle between these 2 points. Okay, then we can say that B is arc length, D is radius, theta is theta, then theta equal to B by D, right? Like arc length by radius equal to theta, that is from plane angle. Now if we see, D will be equal to B by theta. This is parallax method. So first method is to find the distance of an object. Okay, how far a object is, to find that distance we can use parallax method. Okay, next one is to find the size of an object. Let's see. For example, we are taking the sun. Okay, sun is having d diameter. How to find that diameter? We just do the reverse of this thing. So d is the diameter of the sun. We are observing from point O. So we will first look at one end of the sun, then we will look at the next end. This angle is taken as alpha here. Okay, and the distance we should know. If you know the distance only, you can find the size of the object. So this will be arc length, d is radius and alpha is angle. So from that we will get diameter equal to radius into angle, that is d equal to d alpha. I hope everybody understood the difference of two parallax method. One is to find the distance of an object, next one is to find the size of an object. Is it clear? We will use this formula to do a question right now. Let's take this one. Okay, everybody read the question once. I will give you like 1 minute. Question is visible for all, right? Okay. So what it is given is that moon is observed from two diametrically opposite points A and B on earth. Angle theta subtended by moon is 1 degree 54 minutes. Diameter of earth is given. Find the distance of moon from earth. So first parallax method we have to use. Distance of an object. Given this is the moon O, this is the earth. They observed moon from point A and point B. So diametrically opposite points from earth. B is given in the question, that is 1.27 into 10 to the power 7, and angle theta is also given in the question, 1 degree 54 minutes. What you have to find is distance d. What is the equation for that? Radius equal to arc by theta, right? Radius into theta is arc. So arc by theta should be radius. Now B you can directly take. B equal to 1.276 into 10 to the power 7 meters. This you can directly take this value. It is given in SI units. What about theta? Theta is given as 1 degree 54 minutes. Is it given in SI unit? Somebody please say. Is it given in SI units? Hello, am I audible? Okay. Is no is answer for not given in SI unit or not audible? Okay. So it is not given in SI unit. We just discussed that SI unit for plane angle is radian. So we have to convert this into radians. Given that 1 degree is equal to 60 minutes. 1 degree is also equal to pi by 180 radian. You guys remember this conversion? 1 degree equal to pi by 180 radians. So we can convert minutes to radian as 1 minute equal to pi by 180 into 60 radian. Okay. Now see this. Theta is given as 1 degree 54 minutes. 1 degree 60 minutes. So 60 plus 54, this is equal to 114 minutes. Okay. Then 114 minutes equal to 114 into pi divided by 180 into 60 radian. Okay. Please do this calculation. Substitute B and theta, then here find distance. Okay. So one thing you have to remember while doing NEET is that questions will be very easy, but you have to do the calculation really fast, because as you know, you have to do one question in 1 minute. There are some theory questions, from that you will save time, but still you have to improve your mathematics calculation speed, then only you will be able to score good marks. Okay. So these solutions I will be giving you in the when we share the PPT. For now I am erasing this. Can I erase this? Is it okay? Okay. Now you see this conversion of 114 minutes will be equal to 3.32 into 10 to the power minus 2 radian. I hope you guys got that value. And distance we will get as 3.84 into 10 to the power 8 meters. Okay. Did everybody understood how to do the calculation? First make sure that you converted everything into SI units, then use the known formula to calculate what is required. Okay. Now when we go to errors in measurements, you must have heard these words precision and accuracy. In our daily life we use these words precision, accuracy in almost same meaning only, but actually these words have main difference. As you can see in this picture, precise, this one means precise and accurate. This is not accurate but it is precise. This is not precise but it is accurate, and this is not precise, not accurate. From this, are you able to identify what is precision and accuracy? This is like an archery target, right? I think, is it visible properly, the screen, the picture? Okay. So this is like an archery target. So what is our aim? Our aim is to get the like arrow in the middle, in the yellow circle. So yellow circle is our actual value or true value. If all our arrows are inside that, then we can say like everything is accurate, because whatever is the true value, we are getting that as the result. But precision is completely different thing. Here you see all these arrows are near to the yellow, but they are scattered around, they are not near to each other, so it is not precise. And when here it is not near to the actual value, but all the arrows are near to each other, that means it is precise. So when you are taking multiple observation in your like experiment, like while doing experiment, if your values are near to each other, it is precise. If your values are close to the original value, that is, students, I think, and visible, right? The screen is okay. Thank you. So what we were talking about is precision and accuracy. Precision means when we take the readings, it should be close to each other. Accuracy means the readings we take should be like near to the true value. Let's say if we are taking the measurement of this pen, I told you it's 15 centimeter. Then if I am using a vernier calipers, I am getting values as 15.1 centimeter, 15.2 centimeter, 14.9 centimeters. So the values are close to each other and it is close to the true value. So it is precise and accurate. I am taking another vernier calipers and measuring this. I am getting values as 10.1, 10.2, 10.3, like that measurements. It is not near to the true value, so it is not accurate, but the values are close to each other, so it is precise. So precision doesn't mean the value is correct. Accuracy means the value is correct. Okay. Now let's come to vernier calipers. This vernier calipers and screw gauge are like commonly asked question in our entrance exam. So we will see how to, like, what are the formulas included in this. Okay. Now if you are seeing vernier calipers, you know one equation, that is total reading equal to MSR plus VSR into LC. This equation everybody knows, you have been taking this in your practical like physics practical time. And what is MSR? This main scale is reading is main scale reading, and this small one is vernier scale, and that reading is vernier scale reading. You know how to take that and all, so I am not going deep into those things. But in our exam, entrance exam, this is not the equation that we most need. You need this equation, but you need some other also. The question will be given in this format: M number of MSD is coinciding with N number of VSD. Okay, this will be what given in the question. It will be given as numbers, not M and N, like 20 divisions of main scale is coinciding with 21 divisions of vernier scale. I hope you have seen such question. So what you have to do is that first equate M MSD equal to N VSD. This is our first equation. Then another equation is there, least count equal to 1 MSD minus 1 VSD. Okay, so what we have to substitute is that from this equation 1, what we are getting, 1 VSD is equal to M by N MSD, right? Then that we will substitute in this equation 2. So least count will be equal to 1 MSD minus M by N MSD. So I am taking MSD common, I will get 1 minus M by N MSD. So M will be M and N will be numbers, like 20 by 21 or 19 by 20, like that it will be numbers only. Substitute that MSD will be like 1 main scale division equal to 0.1 millimeter. Like that they will give in the question. Or 1 main scale reading is equal to 0.5 millimeter, 0.5 centimeter, like that. Based on that, you have to substitute what is 1 MSD. Substituting that, you will get least count. This is the most important equation. Okay, from the given things in the question, you can find least count. After finding least count, you have to substitute in this. Okay, MSR, VSR will be normally given, like main scale reading is this, vernier scale reading is this. So that is what is required. Another thing is that sometimes there will be zero error. Okay, so zero error you always have to minus in vernier scale. Okay, so total reading will be this MSR plus VSR into LC minus zero error. Okay, so I hope everybody understood this. What is not clear? Okay, are you talking about this vernier image? Is this image not clear or the writing not clear? Hello? Not clear fully. Is it like blurry image? Now is it okay? Okay. So should I explain everything what I told you earlier? Like if you are not able to see this image, no problem. It's just an image of vernier calipers. You have seen that thing. Okay. So what I was saying is that total reading equal to MSR plus VSR into LC. You have already know that equation, but you need some additional equation to solve entrance question. It will be given as M number of MSD coinciding with N number of VSD. Like 20 divisions of main scale is coinciding with 21 divisions of vernier scale. That will be the question style. So you have to equate M MSD equal to N VSD, and for finding least count we have an equation that is 1 MSD minus 1 VSD equal to least count. So in this we can substitute for 1 VSD from this equation, that is 1 VSD equal to M by N MSD. Okay, by after substituting that we will get an equation for least count. This is the additional equation you need for like entrance exams. First you have to find least count, then substitute it here. In some cases they will give zero error for main vernier calipers also. If zero error is given, total reading will be this term minus zero error. Okay, is that clear? Last line not visible, this one. Okay, if zero error is mentioned, then from this you have to minus zero error, that's it. Okay, that is what I have written there. Now you understood? So main scale reading plus vernier scale reading into LC minus zero error will be our total reading if zero error is present in the question. Now is it okay? Okay. So can I close this? Can we move to the next slide, that is screw gauge? Okay. So now we go to screw gauge. Here just the name is different. Okay, instead of main scale reading there will be pitch scale reading, and instead of vernier scale there will be circular scale reading. This one also you have been using in your experiment, I know that, like taking radius of the wire, for that and all we have been using this, right? So total reading equation is same, that is instead of main scale pitch scale reading plus instead of vernier scale circular scale reading into LC. If in screw gauge 0 error is coming, that we have to minus from circular scale reading. Okay, so sometimes there will be error in screw gauge, so what we have to do is we have to minus it from circular scale. So CSR minus 0 error into LC will come. So this is total reading in screw gauge. Here that n number of VSD, MSD, that kind of complication is not coming. Only thing is we have to find least count here also. Least count in screw gauge is pitch divided by number of circular scale division, CSD. CSD is circular scale division. Okay, so pitch divided by number of circular scale division, you will get what is least count in screw gauge. Circular scale division, sometimes it will be 100, sometimes it will be 50. So it will be given in the question that you have to take. Pitch 90% of the time they will give in the question pitch is this value. If it is not given, how to find pitch? Do anyone know that? What is pitch of a screw gauge? Anyone? So pitch means, I hope you remember when doing screw gauge, you will do one thing. First completely meet two ends of the screw gauge, then rotate it like 10 times completely. You will measure the pitch scale reading and you will divide by 10. So that's what you did, which means if you rotate it one time, how much distance this like main scale reading is showing, that is actually pitch. So what you will do is distance moved divided by number of rotations. So 100 division means 1 rotation, 200 division means 2 rotations, like that. Okay, so 1 millimeter equal to 100 divisions means I rotated one time and the pitch scale reading is 1 millimeter. So like that we can find pitch of a screw gauge. Once we find pitch, we can substitute and find least count. Then these things are normal only, 0 error will be given. But now the problem is how to find 0 error. In vernier scale I told you it is not problem, they will directly give in the question, you just substitute the value. But in screw gauge there is positive 0 error, negative 0 error. Maybe you got confused when you were doing the practicals, because you have to add the negative 0 error, subtract the positive 0 error. Don't worry about all that. Just write this formula only, circular scale reading minus 0 error. If it is positive 0 error, let's say plus 8, if I substitute that, it will be CSR minus 8. And if it is a negative 0 error like minus 2, if I substitute it here, it will be CSR minus 2, that will be CSR plus 2. That's how we decide adding or subtracting 0 error. Don't get confused by this. You only have to find how is it a 0 error, positive or the negative one. So can I erase these things? We will go to the 0 error now. Okay. Can you see these images? Somebody please say. Okay. You can't see. Okay, no problem. It is just a close-up image of our main scale and circular scale. Okay. Okay, now I think it's much clearer now. Okay. So what they have done is, this is main scale 0. This is 0 line, okay, of that pitch scale. And if it is directly coinciding with the divisions 0 of our circular scale, which means there is no error, because that should be the optimum value, right? Like both should be at the same line, which means no error. Now here what is happening, this is our pitch scale 0, okay. Here is our pitch scale 0 and circular scale 0 is below that. Below that means it is showing like 1, 2. Above it is going like 0, 1, 2. It is reading here 2, which means positive 2 is our error. Understood? And here this is our 0 of pitch scale, this is our circular scale 0. It is above the main pitch scale, which means the reading is -1, -2, -3 is coming. If we are going below 0, it will be negative values. If we are going above 0, it will be positive values. That's it. So here negative 0 error, that is -3. You just have to find these values, directly substitute in our equation. Okay, you don't have to change the equation at all. When you substitute these values, it will automatically become plus or minus. Okay, so that's how we can calculate errors in screw gauge. Is it fine? Is it clear for all?
Yes, ma'am.
Okay. So we will go to the next topic. Next one is least count. Least count is, it is applicable for every devices. What is the minimum measurement we can take using a device? That is least count. If you are taking a normal scale, you can, like your normal scale is there up to 15 centimeter. In that, what is the minimum measurement you can take? You can calculate like how measure 1 millimeter in that. One division means 1 millimeter, right? So that you can measure. There are some scales you can also measure like 0.5 millimeter also. So it changes from measurement device to measurement device. For vernier calipers, it depends on like how much vernier scale is there. For screw gauge, it will depend on number of circular scale division. Like that, when you are seeing your weight in the weighing machine, what is the minimum value it can measure? Like you can get, let's say you are 54 kilograms, you will say 54.6. That 0.1 is the minimum value it can measure. Like that is the least count. Okay. Sorry, I'm seeing some no ma'am in the comment box. I don't know what it means. So if you want me to like pause, don't change the slide, something like that, please switch on your mic and say. I may not see the chat box. Okay. So least count, we don't have to say much more. Types of errors we have to see. There is personal errors, instrumental errors, random errors. Personal error, while taking the measurement, we are making some mistake, like parallax mistake and all. Because if we are taking measurement, the measurement should be in our eye level, then only it will be correct. If it is above or below, we can make mistake in the reading. So that is a personal error. Instrumental error, let's say you are using a scale whose measurement, that readings are smudged, blurred, we cannot take it properly. So that is an instrumental error. Okay. Random error means it is not our mistake or the device mistake. It is some unpredictable factor. For example, voltage change, fluctuations or temperature change, that will cause some mistakes, errors in our measurement. That is random error. Okay. Now we are going into like exactly what type of errors are there. There is absolute error, relative error, percentage error. You must have heard these terms. We will see what they are. Now you are doing an experiment. You got measured the values A1, A2, A3, etc. up to AN. Like for example, remember the measuring of this pen, 15.1, 15.2, 14.9, etc. values we got in the measurement. But what is the actual value? Actual value is 15 centimeter. So every measurement is having small error in that, right? So we are, how to get the actual value? while you were doing the practical also, you should have seen, if you take 5 reading, you will take the average of that and write it as final result. So that average is our what? Actual value or true value. Difference of each reading from the true value is called as absolute error with that. So delta A1 means A1 minus A mean, and here it is not mentioned, but we are only taking the magnitude. If it is 14.9, we will not write as minus 0.1. The difference is 0.1. Okay, we will take the magnitude only. And mean of this, average of these values is called as absolute error. Okay. So our individual measurement have a difference from the true value. Average of that difference is called as absolute error. Is that clear? And after finding this absolute error, we will write our reading like this: A equal to A average plus or minus absolute error. Okay, that's how we written. You have seen like voltage equal to 5 plus or minus 0.1 volt, like that. So that is this absolute error what we have mentioned. In case this absolute error is not given, then we will take least count as error. Okay, just in case, let's say we are using a normal scale, we are taking the measurement. I got like measurement as like 15 centimeter exactly. I measured using that, but it is having like 0.1 centimeter as least count, right? That we will write as error. Okay. Now once we find absolute error, we can find relative error by delta A mean, that is absolute error by original value. That is our relative error. If you multiply relative error with 100, you will get percentage error. Is all the type of errors clear for you? Absolute, relative, percentage. You have to use this equations in calculation. So I have to make sure you understood it clearly.
Yes, ma'am.
Okay. Now individual errors is fine, but what if we are using that measured values for something else? For example, take this rectangular thing. I am measuring the length and breadth using a scale. Scale is having some errors. Okay, so its actual value is 5, but I measured around like 4.8. This actual value is 3, but I measured something like 3.2. So there is error in my measurement. Now if I am finding the area, that is length into breadth, I am not using the correct values, right? I am using the wrong value with error in it. So the area will also have error. So how to find that? That is called as propagation of errors. If you are seeing there is mass, measurement of mass has some error, measurement of volume has some error, which means if we are calculating density, it will also have some error, right? How to find that? That is propagation of errors. So there are 3 major rules you have to follow in error calculation. That is, if you are adding or subtracting 2 values, let's say length plus breadth, I am adding, its error will be, maximum error in the perimeter will be delta A plus delta B. Okay, and if it is subtracting also, maximum error will be delta A plus delta B. We don't have to subtract it. If it is addition or subtraction, maximum error will be error in A plus error in B. That is one rule. Second rule is, if we are multiplying z equal to A into B, like 2 values we are multiplying, mass into acceleration, force into displacement, then how the absolute error we cannot find. We can only find relative error here. Okay, so delta z by z is equal to error in A by A plus error in B by B. Okay, so if we are finding work done equal to force into displacement, error in work done by work done equal to error in force by force into error in displacement by displacement. Okay, so this is applicable for multiplication or division. We don't have to change sign or anything. Next is power rule. Here a mistake is there, that here they have given plus. It is not plus, it is multiplication. Okay, so it is a to the power p into b to the power q into c to the power r. Okay, so you can see if this is the combination. For example, moment of inertia, that is moment of inertia is m r square. So I equal to m r square is coming. Then r is having power, right? So delta I by I will be equal to delta m by m plus this power will be multiplied del 2 into delta r by r. This is the meaning of this power rule. Is that clear for all? Please note down this example if you want. Okay. I'm closing this for now. Next, by these three rules you can attend like almost 99% of the question. There is one special condition, that is when calculating the equivalent resistance of parallel combination of resistors or series combination of capacitor where reciprocal is coming. There you cannot directly apply this rule. You have a, like I will give you a formula, you can directly use that formula for that. That is this one. If you are having like parallel combination of resistors, equivalent resistance is equal to 1 by R1 plus 1 by R2, right? Then for calculating error you have to use this formula instead of like applying this rule. Please note this formula. Once you noted it, you can give me a thumbs up. Is it done? Okay. So based on that, let's try one question. That is, please read the question. Okay, as you can see in the board, there is P equal to A cube B square divided by C root D. Okay, we have to calculate percentage error in P, percentage error in each values are given. Okay, so while doing that, let's write P equal to A cube B square divided by C root D, right? When we apply the formula, it will be like this: delta P by P equal to 3 into delta A by A plus 2 into delta B by B plus delta C by C plus root D means 1 by 2 is the power. Okay, so 1 by 2 delta D by D. Is this correct? We are applying power rule here. Okay, and we get relative error. And what is the relation between relative error and percentage error? If you remember, please tell or message in the group. What is the relation between percentage error and relative error? Like if you multiply relative error.
Relative error into 100.
Yes, correct. So relative error, if you multiply with 100, you will get percentage error. So I can just multiply 100 here only, right? I don't have to take an extra step. So here also I am multiplying with 100. Here also I am multiplying with 100. Here also multiplying with 100. Here also multiplying with 100. So delta A by A into 100 is percentage error of A. That is given as 1% here. So instead of doing a whole other calculation, I will just write 3 into 1. That is this. Plus this will become 2 into. What is percentage error in B? 3. Plus percentage error in C is 2. Plus percentage error in D is 4. So 1 by 2 into 4. What is the answer? 3 plus 6 plus 2 plus 2. Answer is 13%. Okay. If you understood this question, please give a thumbs up. Everybody? Okay, good. So this is why, like, if percentage error is also given, you don't have to do an extra step. You can directly multiply it with 100 and substitute it here itself. Okay. So if you have done this, then we can go to the next slide. Is it okay? Okay. Now to calculate significant figures, how do we do that? There are 4 rules. Instead of these 4 rules, I will give you 2 rules. Just remember that. If all non-zero digits are significant, okay, if there is 1, 2, 3, 4 till infinity, any number is present, they are significant. Okay, but if zeros are present, then only we have to see. If zeros are in the starting before the number, we will not consider it significant, which means first non-zero digit on the left is the most significant. So you can see here, in this case, here you can see that, like, this is 123.4. We will not include the first zeros when we are talking about it, right? So these 2 zeros are non-significant. Here 1 will be most significant and 4 will be least significant. Okay. In the next one you can see, so here number of significant digits is 4. Next one you can see, first 0 again, we won't consider it. But what about last zeros? So there comes the next one. If there is no decimal point, these last zeros we won't consider. Okay, because we can simply write it as 2.14 into 10 to the power 4, right? So here also the significant digit will be 3. Okay, now next one. If decimal is there, the zeros after the decimals we will count. Okay, so here 1, 2, 3, 4, 5. 5 will be number of significant digits. Okay, last one you see, first 0 we should not consider. 1, 2, 0, 3, they are significant. Decimal is there, which means last 0 we have to do. So 4 plus 3, 7 significant digits are there. First one will be most significant, last one will be least significant. Okay. I hope everybody understood this, how to find significant digits. So only 2 rules are: first zeros not significant, we will not count them. Last zeros we will only include if there is a decimal point. If no decimal point, last zeros we will not include. Okay. This is for rounding off. If we are dropping something, how to round off. I hope somebody already did in the group, so maybe you guys already know that. If, like, our number is, let's take, we have a value that is 15.37 and we have to round off to 3 significant digits. Okay, then this 7 we have to drop, right? So 7 is more than 5, so we can write it as 15.4. We will add plus 1 here, leave the 7. Now if the number was 15.33, this value is less than 5. So if we are dropping it, it will become 15.3 only. We will not add plus 1 there. This is pretty straightforward. We have been doing that. Rule comes if this digit is 5. Okay, if it is 15.35, then what we have to do, we are dropping 5, we will see the next digit. If it is odd number, we will add 1. If it is even number, we will not add. So this will become 15.4. But if the number was let's say 20.45, then if we are rounding off, it will just become 20.4 only. If it's even number, we will not add 1. If it's odd number, we will add 1. Is that clear for all significant digits? Sorry, rounding off.
Yes, ma'am.
Okay. So, like more than 5, less than 5, you already know. If it is 5, odd number plus 1, even number, no need to add 1. Now, doing arithmetic operations like addition, subtraction, division, multiplication, how do we find the significant digits of answer? For example, if we are doing addition and subtraction, we will see number of decimal places, okay, not significant digits. We will see number of decimal places. So, among these values, least number of decimal places for 12.4, right? Only one decimal place is there. So, our answer should also have only one decimal place. Okay, that is in case of addition or subtraction. Now, in multiplication and division, we are saying least significant figures. Here least decimal places, here least significant figures. So, 12 and 12, only two significant digits are there. So, their answer we already know. What is 12 into 12? 12 into 12 is 144, right? But we cannot write because here it is 3 digits coming. Here only 2 significant digits are there. So, we have to write it as 12 into 12 equal to 2. That is 1.4 into 10 to the power 2. Okay. So, only 2 significant digits are coming. Similarly, here 1, 2, 3 is there, 1, 2 is there. Okay. 25 by 4 is equal to 625. So, here 3 significant digits are coming. We should, minimum is 2. So, we should have only 2. So, we have to write it as 6.2. Here we are leaving this 5. When we are leaving the 5, we have to round off. But since it is an even number, we don't have to add 1. Okay. So, while doing this, we have to consider that rounding off and significant digits. Addition and subtraction, least number of decimal places. Multiplication and division, least number of significant digits. Is that clear? Okay. So, I think that is with the all theory, I guess. Sorry, like till errors and significant figures is done. Sorry. Now we will go to dimension analysis. Okay. Let's see. Give me a minute. It's okay. Coming to dimension analysis, we have our fundamental quantities, right? So fundamental quantities, in terms of fundamental quantities, we have to write the other things. Basically, that's only we are doing in dimensional analysis. There is nothing more. So in this luminous intensity, we are not using anywhere, but these 6 we need. That is mass, length, time, electric current. But instead of I, we will use A, ampere also sometimes. So in questions, you can see sometimes A will be written, that means ampere instead of current I. Then temperature, Kelvin, mole, amount of substance. Okay, so we have few examples here: work, force, velocity, acceleration. Let's try writing this in terms of our fundamental quantities. Okay, for example, work. Let's start with velocity. Okay, let's start with velocity. Velocity is length by time. So dimension of velocity will be equal to L T minus 1. Okay, length by time. So L by T, L T minus 1. That is velocity. Acceleration, length by time square. So dimension of acceleration will be equal to L T minus 2. Now coming to force. Force is equal to mass into acceleration. So dimension of force will be mass M, acceleration L T minus 2. These are like basic ones. That's why I'm going fast. I hope you can like follow me. Now coming to work. Force into displacement. Force we have here into displacement. So dimension of work will be equal to M, L into L, that will be L square T minus 2. Work is same as energy, like potential energy, kinetic energy, any kind of energy you take, you can use this one only. Okay, M L square T minus 2. Force, velocity, acceleration. I hope everybody understood how we are using dimensional formula for like writing derived quantities in terms of fundamental quantities. That is dimensional formula. Okay, is that clear? Is that clear? Okay. Now another use of dimensional formula is when we are adding two quantities, those quantities should have same dimensional formula. If I say 5 kg plus 10 centimeter, does it have any meaning? I can add 5 plus 10, that is 15. But 5 kg plus 10 centimeter, it won't have any meaning. If I am adding, I can add like mass only to mass, right? 5 kg plus 0.5 kg. Like that I can add. So similar same dimensional quantities only we can add. But you have seen that potential energy minus work, or work is same as potential energy. That just means that they have same dimensions. Okay. Similarly, if you are equating two things, on the LHS side and the RHS side, things should have same dimension. So basically in this means here S is equal to UT plus half AT square, which means dimension of S is same as dimension of U into T is same as dimension of AT square. And 1 by 2 is a whole number. Whole numbers don't have dimension, like pi or E or theta you are taking, they are dimensionless quantities. But other things we will write with dimension. Okay, so these two we are adding, so they both have same dimension, and we are equating it to S, means it should also have same dimension. That is the dimension analysis means. Okay. Now let's start with questions, PYQ questions. How much we can do, we will do in this class. Okay, I will give you 1 minute to read this question once. Not visible.
Visible.
Okay. me something honestly. Before this class, if you are just attending an exam and you see this question, will you attend it or not? If I was in your place and I am reading this question, I will not attend it because it is too complicated from the starting. See, a balloon is made of material with surface tension. From that word only it will go, surface tension. No, I am not attending. But when you read it completely, you will come to this point. From that you can understand that rest of the question you don't need. We need only that formula. Okay, all these other things they simply gave to confuse us, like to make us panic. What they are asking is T is proportional to these quantities. So in what ratio it is proportional? It is just like F proportional to X. So like that they have mentioned. So if T is proportional to this, both sides should have same dimension, right? We just have to equate that dimension. That's it in this question. Okay. Let's see. So on the LHS we have dimension time T. Its dimension should be equal to dimension of surface tension to the power alpha. Dimension of A is given as what? Area. So area to the power beta. Then rho. Rho is density to the power gamma and radius to the power delta. You just have to equate this, find alpha, beta, gamma, delta. If you just find that, you will get the answer. So for time we can say M0, L0, T1. This is LHS side, right? Surface tension is nothing but force by length. Okay, surface tension is force per unit length. Force we know M1, L1, T minus 2 to the power alpha divided by length. So L to the power alpha. This is surface tension. Area we already know, that is L square to the power beta. Density is what? Mass by volume. So mass to the power gamma divided by volume is L cube to the power gamma. Radius is simply length. So length to the power delta. What you have to do is, for M power should be 0. Total power of M in this side should be equal to 0. So here alpha, M alpha, M gamma is coming. So alpha plus gamma is equal to 0. First equation we will get. Okay. Next take for L. L also total power should be 0. So from here you can take L alpha is here, L alpha is here, it will get cancelled. We don't have to take that. Coming to here we have 2 beta. Then here minus 3 gamma equal to what? Plus, 1 delta is also there. Plus delta equal to 0. This is second equation. M, L. Now T should be 1. So minus 2 alpha. Then no other T is there. So minus 2 alpha should be equal to 1. Which means alpha should be equal to minus 1 by 2. See the options. We found first power, right? Alpha equal to minus 1 by 2. It is coming in here and here. Alpha equal to minus 1 by 2. So we can eliminate two options there itself. Then alpha is minus 1 by 2. Gamma will be 1 by 2. In this, gamma is given as minus 1 by 2. Here gamma is 1 by 2. Without even solving the others, we got A is the answer. Understood? Like, even though it is very complicated, in like 3 steps we got the answer. We didn't have to calculate beta and delta also. Is it clear for all?
Yes, ma'am.
Okay. Okay, so that is first question. We will see next one. A is the answer. Next one, it is about vernier scale, what we explained in class itself. Can you try by yourself? I will also start in like 1 minute. Okay, so a spherical object diameter is measured using vernier calipers. Its 10 vernier scale division, 10 VSD is equal to 9 MSD. Okay, so first equate that, 10 VSD equal to 9 MSD, which gives us 1 VSD equal to 9 by 10 MSD. Write till here and then stop. Then 1 main scale division is 0.1 centimeter. So 1 MSD is equal to 0.1 centimeter. So you can take this approach, okay, whatever is given in the question, write down given, then what we have to find. Like that you can write in a like proper way and do. Then 0 of vernier scale is at 0.1 centimeter. So 0 error is there. 0 error is equal to 0.1 centimeter. Okay. Now main scale reading is 5 centimeter. Coinciding vernier division is 8. Now we have to find total reading. That's it. Least count equal to 1 minus 9 by 10 into MSD from our previous equation. So this will be equal to 0.1 MSD. MSD is equal to 0.1 centimeter. So this will be equal to 0.01 centimeter. That is least count. Now while substituting it to total reading is equal to MSR plus VSR into LC minus 0 error. Okay, sorry, there is no space. MSR is given as 5. So 5 plus VSR is 8. 8 into 0.01 minus 0.1. So this we will get as 5.08 minus 0.1, that is equal to 4.98 centimeter. Okay, so the answer is option A. Is this question clear for all? Okay. Okay, can I clear this board? If you understood means, okay. Answer is option A. Next one is again error calculation. In an electrical circuit, voltage is measured as 200 plus or minus 4. So this is V plus or minus delta V. And current is measured as 20 plus or minus 0.2, which means I plus or minus delta I. Okay. Now value of resistance. What is the equation for resistance? Ohm's law. Remember Ohm's law. Resistance equal to V by I. So division. In division our formula is delta R by R should be equal to delta V by V plus delta I by I. Okay. R equal to V by I, so 200 divided by 20, that is equal to 10. You don't have to calculate. Every option it is 10 only. You only have to calculate this delta R. So delta R should be equal to R into delta V by V plus delta I by I. Right? So R is 10, delta V is 4, so 4 by 200 plus delta I is 0.2 divided by 20. Calculate this, you will get the answer. If you get, you can post in the chat. If you do first, we can, yes, option B.
Option B.
Yes, this is equal to 0.3. So answer is option B. Okay, very good. Okay, can we move to the next question then? I hope everybody solved. As you can see on the board, these all are previous NEET questions. Okay, so like it will benefit you when you are solving this. Next is based on screw gauge. What is given? Error free screw gauge, which means there is no zero error. Happy. Pitch of an error free screw gauge is 1 millimeter. So pitch is given. There are 100 divisions on the circular scale. Number of circular scale division is given. While measuring the diameter of a thick wire, pitch scale reading is 1 millimeter. And 63rd division on circular scale coincide with the reference. Diameter we have to find. Since it is error free, total reading we can simply find pitch scale reading plus circular scale reading into LC. What is least count? Least count equal to pitch divided by number of divisions, right? So that is equal to 1 millimeter divided by 100, that is equal to 0.01 millimeter. Okay. Pitch scale reading already given 1 millimeter plus circular scale reading 63 into 0.01 millimeter. So this is equal to 1.63 millimeter. Is that answer given in the option? Can you find this answer 1.63? 1.63 millimeter. It is not there. So what we have to do? We have to convert. It is given either in centimeter or meter. Centimeter means into 10 millimeter, 1.63 into 10 to the power minus 1 centimeter. That will become 0.163 centimeter. Is that? Yes, option is there, that is B is the correct answer. Okay, so sometimes you will get the correct answer. You just have to focus on the unit also. That's why your physics teachers have been saying if unit is not there, they will reduce half mark. Because of unit, you can miss the option. Okay, so I guess we can stop here for today. Rest we will continue in next class. I hope everything is fine. If you have any feedbacks, you can mention in the like chat box or group. And next class will is chemistry. It will start at 12 o'clock after half an hour. Okay.